Although some of you have never actually seen a real glass and metal vector scope or a waveform monitor mounted in a rack of broadcast gear, this equipment is now available in all professional editing applications. And there's even a company called Serious Magic that makes virtual ones that you can use in the field on a laptop. There are two reasons why you should care about these monitors. First, they can help you improve the quality of your video, and second, they're surprisingly easy to use and understand. We're going to prove that second point to you here in the next few minutes and get you started on a new career in broadcast engineering here on TechKnow. Digital media and computer editing have greatly simplified the task of producing programs for broadcast over the past decade or so. Unfortunately, computer editing can also introduce technical problems that can lead to poor quality images on the television screen. An example of this is when we drop a very bright title on top of our video. The title composition can look fine on a computer, but if it pushes the video signal out of spec for broadcast, you can get significant clipping, tearing, ghost images, or even a buzzing in the audio signal. These sorts of out-of-spec signals are easy to identify with a waveform monitor. Another area where objective monitors can help us is when you need to perform a color match. For example, when you need to get the color of a product or brand exactly right, you can verify your shot on a vector scope, or you can use your editing software's monitors to line up and match multiple cameras more accurately. In any case, vector scope and waveform monitors are much easier to read and use than you might think. So let's power up our gear and send a signal through it. A vector scope is a special type of oscilloscope that displays an XY plot of the two chrominance channels, the U and the V in the YUV color space. This circular reference overlay is called the graticule, and the green line that the oscilloscope draws on the screen is called the trace. The amplitude of the trace from the center of the vector scope measures the saturation of the chrominance signal, while the position of the trace around the circle measures the hue. Let's take a look at these targets on the graticule. We have red, green, and blue targets, as well as cyan, magenta, and yellow. If we throw a solid, fully saturated red on the screen, the trace should land right at the center of this red target. Here's the distinct pattern you'll see if you send a set of NTSC color bars to a vector scope. The fully saturated colors go all the way to the center of the targets. Decrease the saturation and the trace shrinks. If we adjust the hue on the bars, you can easily see the pattern rotate out of phase. You've probably seen the NTSC color bars and heard the 1 kHz tone at the beginning of a tape meant for broadcast. When viewed on a vector scope, a broadcast engineer uses these bars to verify the technical quality of a program and calibrate the chrominance and luminance levels for it. A vector scope can also be used in the field or back in the edit bay to line up or match different cameras used in a multi-camera shoot. By pointing all three cameras at something white, you can white balance them manually. You can immediately and precisely see the difference between the cameras on a vector scope. The trace here should be exactly in the center of the plot. By adjusting the camera's RGB color levels, or even easier, adjusting the color back in your editing software, matching shots is fairly easy with a vector scope. Vector scopes are almost always paired with a waveform monitor, and the two devices together can really tell us a lot about our signal. Like the vector scope, a waveform monitor is also a special oscilloscope that displays the voltage levels of the various lines in a video signal over time. This corresponds directly to the luminance or brightness. Essentially, a waveform monitor can be thought of as a light meter of sorts. There are some other broadcast engineering type signals that can be seen on a waveform monitor, such as the color burst, the vertical blanking interval, closed captioning, and even the V-chip rating system. For our purposes, however, we're going to limit our discussion to the video levels. The horizontal lines on our waveform scale here go from -40 to over 100 IRE. The unit here is the IRE, which is named after the Institute of Radio Engineers, which first developed the scale. 0 IRE is considered blank, and 100 IRE is white, with -40 IRE reserved for a sync signal, and the over 100 IRE levels are for transient peaks. The levels in an NTSC broadcast legal television signal in the United States span from 7.5 IRE, which is black, to 100 IRE. A signal that averages over 100 is going to be blown out and overexposed. If your camera has a zebra stripes feature and you set it to 100%, all of the zebra pattern areas would show up on a waveform monitors at levels that average at or above 100 IRE. Now, this doesn't mean that the video is wrong, it just means that you aren't getting any detail in these areas, which is fine in this particular shot, for example. What you want, of course, is a subject that is properly exposed, not too dark and not blown out. And we can see this very clearly and with absolute certainty on a waveform monitor. Properly exposed subjects will come in between 70 and 100 IRE with some transient peaks over 100. And that, in a nutshell, is what these two monitors are all about. With a vector scope monitor to analyze the color and a waveform monitor to analyze the brightness, we can objectively assess the quality of our video with some confidence. I hope we've convinced you that the vector scope and waveform monitors can both be important when shooting and back in the edit bay. I hope you can also see how accessible and easy the vector scope and waveform monitors are to use. So fire up your editing application and check out the monitors before you render out your next project.